So welcome to Seen and Solved. I'm your host, Tim Pennington. Today's episode is Clean Before You Shine, Mastering Electroless Nickel Tank Preparation. We'll examine why proper tank prep is essential to achieving uniform, high-performance nickel deposits, and the common pitfalls that can shorten bath life or lead to defects, and how proper chemistry, verification, and operator training can optimize plating results and reduce rejects. Our guest today is Travis Hilton, an application specialist turned operations manager with extensive hands-on experience in plating operations, bath management, and process optimization. We'll be right back.
You're listening to the Seen and Solved podcast, brought to you by Hubbard-Hall. Better results, less chemistry.
So Travis, let's talk Electroless nickel. And from the very beginning, why is tank preparation such a critical step before anybody uses an E in bath? Tell us about that.
It's because it sets the base for everything. If there's anything wrong with the preparation step, then it can do all sorts of damage on the actual tank and the parts itself.
And so what happens if it doesn't? What can happen if they're not really set up properly?
Any number of things. There can be nitric contamination in the bath. There can be failures of all different kinds on the parts. There can be anything, honestly.
Yeah, not good. What we want to say, downtime, rejects, those type of things. So let's take it from the beginning then. Walk us through the key steps in preparing an E in bath tank the right way.
The overall step is that you need to clean the tank, you need to strip the tank, and then you need to pacify the tank. And so that's typically done through a couple steps. And so the first step is getting rid of all of the old nickel solution that's in there. You can either send that through wastewater if you're equipped to deal with that volume of a chelator. Most companies are not. Most end up drumming it up, shipping it out to a third party. From there, you're going to want to rinse it out, try and get as much of the nickel out of there as possible. Oftentimes, it's going to be caked on the sides. It's going to be in the pipes. It's going to be everywhere. Because when an Electroless nickel bath fails, it's going to start plating out on the tank itself.
Right.
From there, You're going to want to dissolve the nickel that's there. And that's typically done through a nitric acid solution. You're going to want that at probably 50% around. And then you can throw a little heat to it, not too much, because that can get dangerous in other ways. And then that should, over the course of, depending on how bad it is, hours to a day, strip all the nickel out and pacify the tank. And so at that point, you've done the first half of the battle. The thing that you need to keep in mind is you have to run it through. Typically, these tanks have heat exchangers. And in those heat exchangers is where it builds up the most amount of nickel because of the temperature in there. And so even if you look at the tank and it all looks perfectly fine, there's probably still nickel in the pipes. Let it go another couple hours just to make sure.
All right. I was going to ask you, is that a visual check you can make? Can you really check if you've cleaned it that well? Or how do you test that?
So you can do a visual check on the stripping of the nickel. You cannot do a visual check on the passivation. However, you can make an educated guess that if your nitric is strong enough and it is not contaminated, then you can assume that it is passivated.
Which leads me to the question, how do you know when a tank needs to be stripped or cleaned or repassivated? How do you know that?
So most shops actually have a set endpoint of, call it 4 turns. And so each turn is based on the amount of solution added into the tank or adds made. And so once it reaches that point, you're going to have to start. The plating rate is going to get pretty unsteady. It's either going to fluctuate up or down, same with the pH, same with the visual look on the parts. They're going to start blistering. They're going to start pulling away from the holes. And so at that point, okay, this bath's on the way out. Maybe you can push it and run some steel parts through it, but not any of the higher performance metals like aluminum or beryllium, at which point you would cut it off, empty the tank, start the cleaning process.
We got different types of EN. You got the high phos, mid phos. So do the prep requirements, are they the same or are they different for those two?
The prep requirements are the same. However, the length of time changes. And so the higher the phos content, the longer it's going to take to strip.
So you mentioned that there were contaminants, residues in there. What were some of the most common types that are in there that could cause trouble if the prep isn't done properly?
It would mainly be in this first step that I mentioned, if there's any nitric left over after clearing it out. After the tank's stripped, after it's passivated, you don't want nitrates to build up in solutions. You have to make sure that you fully clear out the tank of all nitric acid. And typically that's done by refilling and then adding in a caustic or an ammonia-based component to it to neutralize anything that could be there, which in turn leads to what could be another problem, and that would be extra caustic soda built up in there, or residual that then gets into the bath. And so typically the following steps after stripping and passivating the tank is to rinse through all the pipes, fill up the tank with a caustic-based solution, empty that, and then run it through with just clean rinsed water. And then that should get it all ready for the eventual makeup of the new tank.
If the prep isn't done correctly, if it's poor, does that I guess it shows up pretty obviously in the deposits, or?
Well, it'll shorten the lifespan of the bath significantly, and that's the main drawback to it. But it also will show up as, it could be darker deposits if there's still nitrates left. It could be unstable plating rate. It could be, like I mentioned earlier, it could be blistering. It could be really anything, flaking off of the deposits.
When you're talking about the prep, are there verification things or steps to confirm that it's ready for a production run, and are there things that can be checked on that?
So you can check the pH of the solution in there after the nitric step before adding the caustic, and then you can check to see if it's pretty close to neutral before you add the caustic, then it should be fine. Then on the final step, after you fill it up with DI water, you're ready to add in the components, just take a nitrate test strip, stick that in there. If it comes out pink, dump it, run it again, rinse it off, try again.
Well, it all sounds like operator training is the most important thing, is make sure that people understand, first of all, why they're doing what they're going to do, but to make sure they're properly trained. How important is that they have these people that work in these facilities know exactly what they're doing and getting set up?
Yeah, it's the most important thing in the world, because it can, if they're not doing it correctly, it'll half to quarter the bath life, and then you're spending significantly more on product and not getting the desirable results. More stuff gets kicked back from QC, and then everything spirals from there.
And downtime with that line while you're trying to get it fixed and those type of things, which is money they'll never get back. And that's what I hear from a lot of shop owners when they have problems like this. They can never get that money back. It's gone. Out in the field, what are you seeing, and what have you seen that share a problem that you saw, and how did you fix it when it came to getting the tank set up properly?
Yeah, I ran into a shop that they were using town water for their rinsing steps, assuming that it was fine. And it normally is, but in this particular case, there were additives to that were leaving behind residual that was then mixing in with the DI water when they were going to make up the tank, and that was causing failures. When we attempted to rinse the whole thing with DI water, it worked perfectly. Using that to rinse a 300-gallon tank is more expensive for sure, but it is significantly less than having to remake the bath twice as often.
Well, Ian, it's a good product, but it's, like I said, it's a tough product sometimes to run. So I appreciate you taking time out and running us through how to set it up properly, and also how to look for issues that could be corrected. So thanks very much, Travis.
Thank you.
Thanks for listening to Seen and Solved by Hubbard-Hall. For more episodes, visit hubbardhall.com or wherever you get your podcasts. Be sure to like and subscribe, rate and review, and join us on social media. Produced by Awcast.